This video is about solving systems of equations using matrices. Here we have a system of linear equations that we could solve using substitution or elimination or possibly graphing methods. Today we want to learn how to use matrices to solve systems like this, and also systems of linear equations that have perhaps a lot of decimals or fractions, or systems of equations that have more variables and more equations, which are difficult to solve using the methods we've learned so far. First thing we need to be able to do is see how we can write this system as an equation of matrices. And so here we have a matrix times the variable matrix equals the constants. So this matrix of coefficients, 3, -2, 5, and 3, multiplied times the variables x, y would give us the left side of our system. And you should see how if we were to multiply this row times this column, we would get 3 times x plus -2 times y, or 3x minus 2y. This row times this column would give us 5x plus 3y, and it all equals our constants. So this matrix equation is a representation of this system of linear equations. Next thing we're going to do is we're going to enter this matrix into our calculator, as well as this matrix. And we're going to call this first matrix of coefficients matrix A. So on our calculators, we can go to second matrix, and we can go over to edit matrix A. So we're going to hit enter, and then we need to give the dimensions. This is a 2-row by 2-column matrix. So if we enter that, we have 2 by 2, and the calculator gives us our rows and our columns. And now we just have to enter the coefficients: 3, -2, 5, and 3. So there's our matrix A. And now we're going to go back into matrix and edit. And this time we're going to edit our matrix B, which is our constant matrix over here on this side of the equal sign. This is a 2 rows by 1 column matrix, so 2 by 1. And just have to enter our 12 and the 1. So at this point, the calculator has stored these two matrices. And now we need to think a little bit about what's going to happen here. So in general form, we now have our matrix A, this matrix, times the variables equals the constants. And we're going to try to solve this equation for our variables, x, y, because that's what our goal was. We were trying to figure out what x and what y satisfy both of these equations. So we need to get rid of, somehow, matrix A. Well, if this was a number, we could simply divide both sides by A, but this is not a number, it's a matrix. And the way we deal with this matrix A and try to get rid of it is we multiply it by its inverse matrix. So we just finished a chapter in which we were talking about inverses. And here we're saying that if we were to multiply the inverse of matrix A times itself, then that should undo anything that matrix A was doing to our variables, and it should end up, these two should eliminate each other. And we're going to talk about that a little bit more in a second. We have to remember that if we are to multiply matrix A on the left side of this equation, we have to multiply it on the right side. And also because matrix multiplication is not commutative, in other words, order matters in which you multiply now. If we're going to multiply it on the left side, we also have to have it on the left of our matrix B on the right side of the equation. So first, before we do some of that work, let's go ahead and just see how easily we can find the inverse of our matrix. Let's go back to second x -1, or second matrix. This time we're going to name, which means just enter on matrix A, and then right where that matrix key was is the x to the -1st, which for our purposes is going to mean the inverse. And if we hit enter, we see this right now. If these are fractions, it's hard to tell on decimal form. So if we go to math and then enter on So changing the fractions and then enter again. We see that the inverse of our matrix, and you can see some of the numbers look familiar. We have a 3 and we have a 5, but negative 5 are 2 and another 3. So those numbers seem to still be in play, but they're being divided by 19. And there are ways to pretty quickly actually determine the inverse of a matrix by hand, which you'll learn about in geometry class perhaps. And even for larger matrices, there are methods to determine the inverse by hand, but certainly that was convenient to be able to do it on our calculator. So our calculator knows what the inverse of matrix A is. So what we're going to do is kind of go back to what we were talking about here. We want to multiply the inverse of matrix A times both sides. On the left side, when we do that, it's simply just going to give us the identity matrix. So similar to the identity element for multiplication, which is the number 1. When you multiply 1 times a number, it doesn't change it, does not change its identity. Well, if you multiply the identity matrix times another matrix, it doesn't change its identity. In this case, if you're dealing with a 2 by 2 matrix, the identity matrix is just 1, 0, 0, 1. And you could quickly find out if you were to multiply this matrix times any other 2 by 2 matrix, it would not change the matrix at all. So on the left side here, that's all we will have left when we multiply these. And then on the right side, this is really where everything's going to happen here, because if we can go ahead and multiply the inverse of matrix A times our matrix B, which you might remember was the constants over here is matrix B, if we just do that, basically we've got our answer, because the inverse of matrix A times matrix B is simply equal to the matrix XY. And if we know that matrix, then we know our X coordinate and our Y coordinate. So going back to our calculator, we're all set up here. I'm going to delete that, and we're just going to go ahead and enter exactly what we see here. So we're going to go back to matrix. We're going to name matrix A, but we want its inverse, so then we hit the X, the negative first key. And then we could hit times, but it's unnecessary. We're just going to go right back and go ahead and do matrix. And this time we're going to name matrix B. And we're going to hit enter. And sure enough, the solution is 2, negative 3. And we would write that ultimately as a point 2, negative 3, but as a matrix it would look like this. And we could certainly check to see if that answer works. If we plug 2 in here, we're going to get 9 minus, 6 minus negative 6 is 12. And if you put 2 in here, you get 10 plus 3 times negative 3, which is negative 9. 10 plus negative 9 equals 1. So that checks out. So quickly reviewing the key steps, we're knowing how to translate this system of equations into a matrix equation. And then very important was this idea of undoing matrix A by simply multiplying it by its inverse. And by doing that to both sides, we still have equality. And then that ultimately leads us to the fact that the matrix XY is this simple idea here of the inverse of matrix A times matrix B gives us our matrix and our final answer. So I hope you will be able to extrapolate upon this idea when you have more challenging systems than this particular example, but please use this as a good example to move forward. Thank you.